In this video, we're going to take a look at how to name molecules that contain more than one high priority functional group. Generally, we're going to follow the priority list that you can see over here. So typically, if you have a molecule that has more than one functional group, you're going to figure out what type of molecule it is based on the priority list. So let's say you had both the OH and the amine group here. You have to determine if it's an amine, amino group, or a hydroxyl, an alcohol overall. And so to do that, you'd look at the priority list. And as we can see here, the alcohol is going to have a higher priority list, priority compared to the amine that's over here. So this molecule would be considered an alcohol overall. And then the amine would just become an amino group as a substituent. So you can follow that priority list there. Again, as usual, as we saw in the previous video, the double bond will take priority to the triple bond if there's an equal choice. Otherwise, just number to the end that's closest to the double bond or triple bond if there's nothing higher priority than them, of course. So essentially, we're going to number based on the priority list you see here. You can also find the priority list on our main calendar. So if we go up to our calendar over here, let's scroll up. Priority list like this. Priority list can be found essentially on this diagram here, on this table here. The only thing to be aware of is that the ether, halogens, alkyl groups, phenyl groups, nitro groups, they're all on the same level. Even though on that table it looks like they're not, they are. And don't forget, nitro is NO2. So let's go ahead and try naming this molecule here. We just figured out that it is an alcohol because this is a higher priority group. And so what we're going to do is we're going to number starting from the OH group. So 1, 2, 3, 4, 5, 6. That means our substituent is a 6 amino substituent. How did I know it was called amino? Well, if you go to your list here, you'll see that when amine is not an amine, when it's not the main group, we call it amino as a substituent. So 6 amino, and then we have hexan 1-ol. You don't have to put the 1 there, so you can just put hexanol. Let's try this next one over here. So we need to figure out what type of molecule we're dealing with. It looks like we're dealing with an alcohol again. We want to get that one to have the lower priority, or the higher priority, so lower number. So we'll start here. So 1, 2, 3, 4, 5, and 6. And so this is another 6-carbon molecule with a 6-carbon parent chain. We have our substituent at carbon number 5. So we have a 5 amino. And then it's a hexan 2-ol because it's a position number 2. So 5 amino, hexan 2-ol. Let's go see our next example over here. Wow, we have a lot of functional groups here. Okay, so it looks like we have, what is this? Oh, this is hydroxyl, and this part here is actually what would typically make an ether. This is called an alkoxy group. So what do we have? Do we have an ether? Do we have an alcohol? Let's go take a look at our priority here. So it looks like ethers come later. They're not high priority at all. Alcohol's going to win this game again. So this is an alcohol. We're going to treat the rest as substituents. We actually have a diol here. So let's name it to get our lowest values possible for our OH groups if we can. So we have 1, 2, 3, 4, 5. This is a 5-parent chain carbon, and then this just counts as a substituent on that carbon number 5. What do we call the substituent when it's not an ether? Well, let's go take a look. When you have an ether, but it's not an ether, It's basically we use the ending oxy. So instead of saying methyl, you'd say methoxy. Instead of saying ethyl, you'd say ethoxy. So it's the same approach as if you're naming regular ethers. So here we have two carbons that are attached to the O. So this is a ethoxy group, and it's on carbon number 5. So it's 5-ethoxy. And then we have its pentane. The reason I'm doing that is because if you remember, this is a diol. And when we name diols, as you can see over here, we write the full name of the molecule, and then we put the location and then diol after that. So pentane, and it's 1,3-diol. And so that is our molecule name based on the substituents, and there were multiple, based on the priorities, there were multiple functional groups that had high priorities. We would choose the highest one to select what the base of our molecule would be. There's a few other examples that you can see over here where we have multiple functional groups. So you can take a look at these. The answers are provided for you directly below, but take a look at the molecule to see if you can figure out why they're named this. So for example, over here, there's nothing, high priority. So it's simply a heptane molecule. And then all these are considered their substituents with the carbon number 1 numbered as such because we get a lower value at our first point of difference. Now, if you look over here, we have 4-oxopentanoic acid. Oxo is the name you would give to a ketone if you didn't have it as a ketone. There was a higher priority there, and the higher priority is the carboxylic acid that you can see there. Here you can see we have, let's go over here. Let's go down to this one, which we've done already. We have pent4 ene1-ol. This is naming an enol. So we've done that, and you can take a look at why we call it that, because this is a higher priority here. So we had to give this one a lower number, and that's how we end up with a 4 for our double bond. So we're doing pent4 ene and then 1-ol. Let's look over here. Why do we have chlorine with such a high number? Well, it's because we have a triple bond over here. And so that triple bond takes priority to the alkyl groups. And we didn't really see this functional group, so don't worry too much about that, but you can take a look at it to see if you can figure out why it might be named as such, just to gain some practice. Try the deciphering some of the rules on your own, which could be a good experience for you. And then here we have a hydroxy cyclopentanone. This one here is a bit of a weird one. In reality, based on the rules I taught you, your highest priority would have been, let's go take a look. We have the OH is higher in priority. Actually, nope. Yeah, the double bond it's not a way around at all. The double bond is higher in priority there than the OH by itself. So that works. So this is our substituent of OH. And so we have 2-hydroxy. This would be the first carbon. So cyclopentanone. So it's basically a ketone, but we have to put cyclo in the front because it is a cyclical ketone. So again, that's a good exercise to go through those molecules to see if you can figure out why the names are the way they are. A really cool exercise to do as well is just find some molecules in your textbook or your notes, or just sample molecules, maybe even online on Google Images with names next to them, and see if you can figure out why they're named that way based on all the functional group knowledge that you have. Keep in mind that sometimes you might see an old naming system like this one over here where we put the 4 in the front rather than in between there. Make sure you still follow the naming system that we learned in class because it's the more up-to-date naming system. And of course, if you're doing this work, you can go check your work by going to our document here and highlighting to see if you were on the right track. So over here we put 5-aminohexane-2-ol. Over here we put 5-ethoxypentane. Oops, I forgot the N there. Pentane. Let's see if that fixed it. 5-ethoxypentane 1,3-diol. Did we put that? Just want to make sure I put that. 5-ethoxy pentane 1,3-diol. Perfect. So we named molecules with multiple functional groups. We have to make sure we use our priority list to determine what type of molecule we have, and then everything else will be considered a substituent based on this priority order that we see here.